Good morning, good evening, good afternoon, wherever you're joining from. This is Raman, and let me extend a very warm welcome to each one of you joining in. We know how busy you can be, so really appreciate your time. Today, I think we have a lot of our customers on the call across the manufacturing sub verticals, a couple of our internal staff, and then we have a very special speaker. So it's going to be a cracking conversation. I just can't wait to get started. We are going to talk about digital twins today, right? Now, as our role as a leading IoT platform builder globally, we talk to leadership across each of the sub verticals in manufacturing, right? And repeatedly we hear from their leadership is, hey, we get the what part, right? We know what needs to get done, so we are clear, right? What we don't know is the how, right? Is what are the steps to really make all these good things happen. Things like smart factories, things like getting to zero unplanned downtime, reducing planned and unplanned maintenance windows, right? And really improving, or perhaps really understanding the connection between how a machine productivity leads to an increased operator productivity, and the combination of both hopefully results in improved plant metrics, right? And so we thought, hey, why don't we take a stab at connecting some of those dots, right? And talk about digital twin alone. Before we do about us, right? Now, IoTfy is a part of the Simcon Software India group, right? And we have been in industrial automation for the last 30 years now. This is all we have done. This is all we know. We do nothing else, right? This is our niche. And off late, we realized that, hey, we already have this competence, so why don't we spin this off as a separate company? And that's the genesis of IoTfy. So while we may be new as a company, I think we carry a 30-year legacy in a very niche, hyper-disciplined field of industrial automation. Right? Now, our point of view on IoT is that if you look across the value chain, there are parts of it that are easy to do and some that are not. Things like visualization, things on PaaS platforms, things on, I would say, even data management are kind of easy to do. Most systems integrators can do that. Things that are hard are things like sensors, sensor enablement, sensor to platform connectivity, bringing machine learning models from cloud closer to your high value assets, getting near real time analytics. And those are harder problems to solve. And that's our niche. That's what we do. Today we are a bunch of 200 plus R&D engineers. Most of our work is on firmware and embedded engineering, hardware architectures, and really building, solving some of these more complex IoT problems, right, which most people can't. So with that, let me jump in and introduce Ronnie. Ronnie is a senior consultant with us and a general manager. He advises clients like you in coming up with a roadmap, right? An Industry 4.0 roadmap. Today, he would restrict his conversation to digital engineering alone and how to enable that. Now, in terms of rules of the road, we would mute the webinar for about 20 minutes and hear from Ronnie. And after that, we would open the forum and, for everybody to kind of come in and any questions that we can take. So it's going to be a super exciting day. I certainly am. And so without further ado, let me hand it over to Ronnie. Hey, Ronnie, come over. Let me hand this over to you. We'll just sit back and listen. Thanks.
Hey, thanks, Raman. Thank you for the introduction. Good morning, good afternoon, wherever you are. Absolutely pleasure to be a part of this webinar on digital twins. So before we get started with digital twin, I wanted to kind of present a brief perspective about what we think digital twin is. I know everyone who is a part of the manufacturing industry or people who have been working on the process side, operational side of various businesses, I think everyone is fairly, sort of aware in terms of what digital twin, can offer for their specific businesses. Which also means that I think everyone in the industry, exploring digital twin will have a certain amount of understanding about digital twin. And it sort of might have some subtle differences, in terms of how an individual perceives digital twin, to be in the first place. And I think everyone is right in their own perspective, but it's just that when we try to look at implementing a digital twin specific to a certain business need, we have to really look at certain granularity and certain aspects of how and what, component of digital twin would be apt for their business line. So I would probably start with a brief about defining digital twin, trying to make it, a little bit more simpler to understand. And then I will try to, kind of look at how, a digital twin kind of makes a smart factory that much more data driven, and what are the benefits that it kind of brings into a smart factory, who have a digital twin implemented. Also, what are the kind of digital twins that we see today in the world we live in? Then finally, the fourth topic that I would want to cover would be how technologies contribute to the aspect of digital twin. So, what are those technologies that are sort of impacting digital twin, and how it contributes towards making it a success? That will be one of the topics. I mean, the fourth topic that I would probably want to cover. And then, at a high level, if you are really sort of trying to implement digital twin, then where you should start? What are the steps that you should basically take? And I think towards the end of my presentation, I will probably want to leave by kind of asking certain set of questions for the audience to kind of think about how they really want to perceive a digital twin. What are the questions they should be basically asking themselves before they actually get started on the ground? And finally, I'll open up for some question and answers. So that's more or less the agenda I have for today. So I think jumping straight in, let's probably start at looking at what exactly is a digital twin. Now, as I earlier mentioned, that I think everyone have their own perspective towards defining a digital twin. And I think everyone is correct in their own way. But to kind of have its holistic benefits, you really have to have a 360-degree view about what you are trying to accomplish as a part of the digital twin. Now, let's get started in terms of having a very clear understanding in terms of what is a digital twin, right? So even before we try to get to understand what is a digital twin, let's try and first understand what is a biological twin in the first place. So for example, we humans, right? So we are sort of, defined in a certain way, that kind of makes our personality. So similarly, when we try to look at envisioning digital twin has been thought of, with the characteristics or aspects, of a biological twin, in terms of how a biological twin evolves. So with that as a reference, digital twin basically has been thought of, to kind of create a digital replica of an original asset. Now, if we go back to understanding what exactly is a biological twin, we need to understand there are three intrinsic factors that sort of define a biological twin. First is, there is a characteristic, then there is an attribute, and then there is a behavior. Now, most importantly, in the world we live in today, I think all these three, factors from a biological twin perspective, seem to be kind of used interchangeably. But in the world of data, in the world of machine, and in the world of kind of creating a digital twin, it's important to really understand the nuances that each of these kind of bring in terms of defining a digital twin. So a characteristic is basically an aspect that an asset or a machine would be typically born with. So these are things that we cannot really change about an asset. So that's what is a characteristic. So these are something which are the imbibed kind of factors that sort of make a machine when it is kind of created. So then comes the attributes. So for example, once a machine, or an asset is created with a certain characteristic, there will be certain factors or derivatives that it will basically, kind of imply towards, or it'll probably create. So which will be basically taken from characteristic being kept as a reference. So that's basically an attribute. So an attribute is more of, creating a derivative out of the characteristic that an asset is defined with. And then finally, a behavior is something which is kind of a combination of characteristic and attribute put together, along with certain choices and kind of decisions that probably an asset can make in time. So essentially, what we really need to understand is that a behavior is something that can be changed, if need be, with time. But characteristic cannot be changed with time. That is something that is really an asset is born with, so to say. So these are the three important factors that kind of define a digital twin in the first place. So with that as a prelude or a start, let's look at what are the components that basically a digital twin bring in. So why do we really need a digital twin? So what does it kind of bring to the table? So first of all, when we're trying to create a digital twin of an asset or a machine, we would basically have a real-time visibility and monitoring abilities of those assets. We can certainly have remote control established for those machines or critical assets. So which means that you really you don't really have to have those machines manned, on the floor, but you can basically control the assets, remotely. And most interestingly, I think as because it's kind of a digital replica of the actual asset, like an actual asset should have its own identity. It should have its own processes that it kind of gets governed with, and also the interchangeable information exchange that it would have with other systems or machines. Similarly, a digital twin needs to be also defined, and the definition of those digital twins are kind of governed primarily by creation of a digital identity, creation of sort of the processes that govern that particular asset, and what are the systems that particular asset or a machine is sort of linked to. So these are the most important sort of attribute in terms of how an asset or a digital twin in terms of an asset is sort of defined. With that as a backdrop, I would probably want to look at how smart factories can actually benefit from this. So some of the business benefits that immediately comes to the mind sort of implies that they would have real-time visibility, and they can also have conditional monitoring of assets kind of put forth. For example, if an asset is sort of about to fail, or if there is a change in its behavior, which is sudden, certain alerts, notifications can be immediately generated at the machine level, and accordingly appropriate steps can be taken to ensure that the asset doesn't really fail in time. Some of the backend processes, can be certainly automated and orchestrated as well. We can ensure that there can be machine-to-machine inter-exchange of data and information that can be kind of also established. Obviously, there can be, like I said, with remote control of assets, these assets doesn't really need to be manned, physically on the floor. So that's one of the biggest advantage, and thereby the human dependencies can reduce, and also most of the errors that are human driven can also be reduced. Similarly, the planned maintenance cycles can be established and driven. You can have your inventories, your supplies, all of that mapped from the real-time data that gets generated from the asset on the field. So you can have a connected supply chain experience, and all of this can be tied to creating a customer 360 view. So your customer is also aware in terms of what is really happening, and if there are any delays or if there are any changes, all those change of events and everything can be shared with the customer, so the customer is well prepared and there's no drop in terms of customer satisfaction, and it all kind of relates to an enhanced customer experience. So these are the business benefits. Now, how can these benefits be tied to a leaner data thinking? So obviously what happens is, when you're able to have these sort of systems defined, you would be able to effectively share data. You would be able to have operations driven remotely in real time. You can even try conducting a lot of simulations and experiments. Now what happens is, in manufacturing, in heavy machinery, most of the assets are critically intensive and kind of capital intensive as well. So there will be if I'm doing certain experiment during production, if it fails, most of the raw material and other costs kind of go a waste. So if I can try and conduct those simulation experiments in the virtual world using the digital replica or the digital twin, that sort of ensures that a lot of costs can be saved. And also all of this can be sort of defined, stored, and shared. So there is a lot of trust that sort of gets built, because at every level you are very well aware of what's happening in the production floor, how your machines are behaving, how the maintenance cycle, supply chain, all of this is sort of tied, and then also how all of this can create greater collaboration both internally as well as your external factors like customers and so on. Coming to the types of digital twins. Now, firstly, we need to understand in the broader concept, primarily there will be an initial twin, which is called as a discrete digital twin, and then there is a composite digital twin. So what is a discrete digital twin? So discrete digital twin is basically a digital replica of a single entity, and it doesn't really kind of relate to the systems it sort of is connected to, the processes and so on, but only kind of creating diagnostics or creating visibility to that single entity itself in real time. So for example, you can imagine a discrete digital twin of a gearbox for real-time monitoring. That could be an example. And then when we look at composite digital twin is again an aggregation of multiple discrete digital twin. So that's one component that we really need to understand in terms of envisioning digital twins. So where do you start? So typically when you try to start, you would probably want to envision with one single asset, one single machine, and try to create a discrete digital twin first, and then try to go to the composite level. So a composite digital twin can be something like a smart factory. Now, this is basically the the broader kind or type of digital twins that you can think of. But in perspective, there are multiple variations or variants of a digital twin that one can think of. First could be a status twin. Now, a status twin is basically something that kind of gives you real-time alerts, it gives you real-time data visualizations, as well as it can kind of give you some conditional monitoring oriented statuses as well. So for example, if a machine has been running in a green state with all okay signs, and suddenly if it moves to amber, then an alert mechanism would be basically raised. So that is what you can basically visualize. So that kind of a digital twin would fall under the category of a status twin. The second would be an operational twin, where it also kind of gives you some decision making ability. So it kind of gives some decision making abilities to the operations and field agents to make them sort of more reliable. And that typically would be tied to a set of actions. So this is one component where, let's say people in operations in the field can really benefit or help, get help from this sort of a digital twin function, which is categorized as an operational twin. And then finally, there is a simulation twin as well. So for example, where the digital twin can also look at predicting outcomes, forecasting outcomes and so on. So this is where you basically kind of employ AI, machine learning, and data algorithms. So aspects like predictive maintenance. When would a machine, when is the machine going to fail, for example? Can I predict that event even before it has happened? So that's basically the benefit of what you can get out of designing a simulation twin itself, where even before, let's say you're trying to produce an automobile, a car, or a certain component of a car or a vehicle, if you really can envision this entire production cycle well in advance before you actually try getting to actual production, you can save a lot of cost. So for example, let's say you start with a production cycle and with some designs and things that you think is appropriate, and you get on the ground starting to implement those, and suddenly there are surprises, there are issues which lead to a failure. That means all the costs that kind of go in, right, from raw material to investments on labor and time, everything gets wasted, because the aspects of manufacturing, factories, these are all asset driven. So these are all capital intensive. So these kind of failures, if you can actually predict or preempt or visualize well in advance in the digital world, that is basically something that can add a lot of value and can save a lot of costs. So that component or that bucket of a digital twin would fall under the category of simulation twin. So what we really need to understand is, now, to get to these twins, the base component that one has to really take care of is basically the data layer. So the data layer is very important, which really comes to determining the success in terms of the digital twin implementation. So when I talk about data sources, what kind of data it is, so is the data coming out of thermodynamics oriented or geological oriented information, or is it coming out of assets that kind of give some historical data about the machine performance, with which you can actually do some time series forecasting or do some analytics. So different kind of data would have different kind of modeling techniques. That's where your AI and machine learning comes in. So the critical component here that we really need to understand is, how do you structure the data layer first? How do you really get the data, collect the data, how you source the data? So sourcing of data comes first. That's where your IoT comes in. And then from the sourcing, how are you collecting the data? How are you standardizing the data? Is the data standardized, harmonized, all of that? And then you try to apply your AI modeling that will kind of give you the outcome. So the crux of this particular slide, what we really need to understand is, when we look at envisioning a digital twin in real time, successfully, if we have to implement, the base component of it has to be the data architecture. So I think that's all I have on this slide. Moving on. So what's really important to understand is to really see what are the technologies that sort of constitute into making digital twin a reality. Is it any one technology that sort of makes a digital twin, what it is, or is it a combination of technologies? Now, it is actually in reality a combination of technologies that sort of define a digital twin. And most importantly, to understand, all these technologies are mostly data-driven technologies. So for example, if you look at IoT, it sort of kind of creates real-time data sourcing. So it generates data. If you look at edge computing, it sort of collects data and also channels data in an intelligent way. And then when you look at the infrastructure component, where there is cloud or fog, or these are the channels where you can either store your information in the cloud, or you can basically have certain information processed closer to the asset, and then kind of also store it in your own data center. Then there is machine learning. So once you have the data gathered and collected, that is where you can start analyzing the data to understand how the data has been behaving. Based on that learning, you can then try to automate that, using AI for some decision making abilities. Most importantly, given that the future of machines is about making a machine or a node independently functioning, there is data decentralization that is happening. That kind of is facilitated by a technology which is called as distributed ledger technology, or DLTs. And then finally, how you render the data, how do you see that as a user experience? And that is where you can have immersive experiences created using augmented reality and virtual reality. So these are some of the main technologies that sort of combines to kind of create a digital twin experience. Now, how am I able to combine these technologies? I'm able to combine these technologies because most of these technologies are built on open standards. Hence, it is easier to sort of create interoperability by combining these different stacks together. Now, coming to the steps that one needs to really create, steps that one really needs to think of if you are trying to create a digital twin. It's very, very important to really have, digital twin is all about setting up the data architecture, right? So how you really get started. The first important aspect is your data abstraction. That's where you start collecting data, gathering data, harmonize your data, standardize your data, because that's basically the base. If the data is not clean, the outcome that it will present will also not be clean. So the first aspect is to collect and gather clean data, which is basically the part of the data abstraction process. And then once you have the data, that's where you try to apply technologies like machine learning and AI to kind of create analytics and intelligent decision-making capabilities. And then finally, when you have the decision, you can basically view it either on a dashboard, or you can view it on immersive experiences created through augmented reality and virtual reality. So these are primarily the basic steps that sort of needs to be thought of in terms of creating a digital twin ecosystem. To create a minimum viable product, usually and again, I'm just talking about maybe creating a discrete twin to begin with. So that would probably take maybe 2 or 3 months in terms of a data cycle. Of course, it can be much more depending on your kind of machine, type of data, volume of data. There are other many factors, that kind of govern the typical timeline in terms of how much time it will take to create, a digital twin. But to think of from a discrete twin perspective, typical timeline would be more or less 2 to 3 months. So with that in place, I think I would want to leave the session by sort of asking certain questions, or I would want the audience to start thinking about these questions if they really want to have a digital twin created in the next few months. There are certain things that you need to start asking yourself if you're really planning on a kind of a digital twin journey. First, do you really need to continuously monitor your assets or machines, and also need to record, let's say, every change event that would have occurred? That's the first question you should ask. Then, does this system that you want to implement, do you really need it to provide certain decision support or decision automation as well that can augment or help your field engineers or your business processes with better visibility? Third, can you really apply machine learning and artificial intelligence to ensure that the system is able to predict outcomes and give you some forecasting or prediction as well? And most importantly, the last question you should ask is, how are you going to think of defining the data architecture? So are these assets or machines, are these going to be independently functioning nodes, or it will be kind of centrally controlled? So that kind of defines how your data architecture needs to be thought of in the first place. So I think these are some of the basic questions you need to start asking yourself if you're really thinking about implementing digital twins in the near future. So I think that's all I had at the moment, and I think I'll be open for some Q&A. If you have any questions, I'd be happy to answer at this point in time. Thank you.
Wow, this was great. Ronnie, thanks a lot. For presenting this to us, for putting this together. We really loved listening into you, and I'm sure it's true for a lot of other folks. So let's see if we can answer a few questions in the time that we have left. Let me look up the chat window, and by all means, feel free to punch in your questions. And here we go. Now, Sashi from a digital manufacturing company, so Ronnie, his question is, what are some of the misconceptions with digital twins? Right? The term, like, most in technology, kind of, this is one of the most overused terms. So what are some of the misconceptions that it carries? And I think what the question also means is that, hey, it just can't be, solve every imaginable problem there is. And so what are the limitations of a digital twin? So that's the question. With that, over to you, Ronnie.
Thanks, Raman. I think it's a very good question. So coming to the biggest misconception about digital twin that I have come across in my findings so far has been that digital twin is nothing but IoT. Now, IoT is basically one of the core component of a digital twin. I would say IoT is basically the start, because that's where you start generating or sourcing real-time data. Now, once you really generate the real-time data, right, how you utilize that, how do you consume that, right, that kind of determines outcome, and that's where you can do forecasting. So it really depends on what kind of twin that we really want to put forth in front of a customer. Now, if the customer really want a visibility with an immersive experience, we can generate the data, collect it properly. But even then, in terms of creating a proper dashboard, just giving plain numbers doesn't really add much value. So in my experience, what I have seen is that most of the customers who are looking to sort of implement a digital twin, they want to go the full cycle, in terms of data generation to data consumption to data outcomes, and then kind of really visualizing the outcomes well in advance before the event can actually happen. So in that context, I think envisioning digital twin as just an IoT is going to be giving incomplete outcomes. So IoT with a confluence of a lot of other technologies like machine learning, AI, immersive experiences like AR, VR constitute a holistic digital twin that can create a lot of value in the manufacturing or smart factory spectrum.